Hey everyone, today we're going to look beyond the usual stuff, the hard hats, the complex schematics, to get to the skills that really make a modern engineer successful. And I'm telling you, the answer is probably not what you're thinking.
So let's just jump right in with a question. What do you think is an engineer's most powerful tool? A supercomputer, maybe? Some kind of crazy advanced software? An obscure math formula that only a handful of people understand? Seriously, what's your first guess? Okay, you ready for this? Believe it or not, it's clear communication. Yeah, that's right. It's not a physical tool at all. I mean, think about it. You could have the most amazing, world-changing idea, but if you can't explain it to your team, or convince a client it's the right move, or write it down so other people can build on it, it's worthless. Communication is literally the engine that turns a great idea into reality. And that idea really gets to the heart of our first section here. Being a great engineer today isn't just about what you already know how to do. It's about constantly learning. You got to stay on top of new tech, see the next challenges coming, and really get what innovations are shaking up the world. So what does this modern toolkit actually look like? Well, at first glance, these points might seem like homework assignments, right? Reading technical stuff, summarizing, thinking critically. But this is the job. This is the day-to-day. It's how you read a dense paper on a new material, pull out the absolute key points for your team, and then make the case for why this, right here, is the game changer you've been looking for. So, how do you actually get good at these skills, the ones that really matter? Well, this is where something as simple as an assignment can actually become a powerful training ground. It's basically a simulation of the exact kind of thinking and communicating you have to do to make it as a professional engineer. Let's call this whole exercise research and reflection. Now, the point here is not to find the one right answer. Nope, it's a practice run. It's about building those mental muscles that an engineer uses every single day to dive into a new idea, understand it inside and out, and then report back on why it's a big deal. Okay, so how does this really work? How can something as straightforward as reflecting on an article actually shape the mind of an engineer? Let's break it down. It really all comes down to three key pillars of inquiry. So here they are, the three pillars. First, you have to summarize the core idea. Can you take something complex and just nail the main point? Second, you explain your why. What about it grabbed your attention? And finally, you make the connection. How does this idea affect, well, everything else? Each step builds right on top of the last, turning a simple thought into a really powerful analysis. Let's look at pillar one, summarizing. The real test here is, can you take a super dense technical article and just boil it down to its most essential message? This isn't just for school. This is a survival skill for those team meetings and client presentations where you have to get to the point, and you have to do it fast. All right, next up is the why. Now, this one might sound a little bit soft, but do not underestimate it. This is where innovation comes from. I mean, seriously, the biggest breakthroughs in history didn't happen because someone was just checking a box. They happened because someone got genuinely curious. Following that little spark of interest, that's what leads to real discovery. And pillar three, making the connection. This is where a good engineer becomes a great one. You always have to be asking, so what? So what if this new algorithm is faster? So what if this material is stronger? How does it actually matter in the real world? This is all about translating a technical detail into its actual impact on society, on an industry, or on our future. Now, as we're building up all these skills, there's a foundation that everything has to sit on. Because in engineering, how you do the work is every bit as important as the work itself. And that brings us to the rules of integrity. You know, when you see rules like no AI rating or no copy-paste, it's easy to think of them as just school rules. But let's reframe that. This isn't just about academic honesty. It's a direct preview of professional ethics. It's about owning your work, being fully responsible for it, and making absolutely sure you understand everything you put your name on. And hey, don't just take my word for it. This quote from the source material hits the nail on the head. These standards mirror real-world expectations for engineering documentation and professional ethics. When an engineer signs off on a blueprint, they're putting their name and reputation on the line. That trust, that accountability, it starts right here. So, keeping all that in mind, what's the real measure of success here? When someone's looking at this kind of work, what are they actually evaluating? So, what's really being measured? If you look at this list, you'll see the focus isn't on picking the smartest or most complicated topic. It's all about showing clarity in your thinking, proving you actually get the material, and putting in the effort to make an original, thoughtful connection. In other words, what's being measured is the process of how you think, not just the final answer you come up with. And at the end of the day, it all comes down to this. The absolute non-negotiable foundation for all these other skills, communication, critical thinking, all of it, is your personal integrity. Proving that you're honest and that you've put in a genuine effort, that's the baseline. That's 100% of the game, both here and in your career. So I want to leave you with this question. The next time you're working on something, anything really, that seems kind of simple on the surface, just stop for a second and ask yourself, what am I really training for here? You might just find that you're building a foundation for something way, way bigger than you ever thought.